So far I've talked a lot about observations and how we can improve them, but we often observe in order to learn something about causal relationships. What depends on what? I'm going to finish our discussion of observations by introducing a framework that we can use to understand how scientists make inferences based on their observations, experiments, and simulations. The logic of observation-based inferences was described by John Stuart Mill, a philosopher best known for writing about liberty, but who also made great contributions to how we think about science. Mill was interested in how we can use observations and experiments to determine causes, or what depends on what. He introduced a series of methods for reasoning about empirical data, which we now call Mill's methods. I'll talk about the first two of his methods, what we now call the method of agreement and the method of disagreement. So to begin thinking about these methods, let's distinguish between outcomes and conditions. Let's imagine there was an outbreak of food poisoning in a local restaurant. The fact that people got ill is the outcome. The different foods that people ate, the different restaurants they ate in, and the health histories of the people are the conditions. Scientists often call the outcomes dependent variables and the varying conditions independent variables, and I'll use these terms. So Mill's method of agreement is simple. Make a table of the dependent and independent variables, and then see what independent variables are shared by all the cases with the same dependent variable. If there is such a variable, Mill's method of agreement identifies this as the cause. So let's look at a simple example with just 4 dependent variables and 1 independent variable, whether or not an individual got sick. In this case, Mill's method of agreement would flag tofu as the likely cause of illness. It's the one food all the people who got sick ate. Now let's look at Mill's method of disagreement. It's closely related. We make the same table of dependent and independent variables, but in this case, we look for a pattern where a difference in the dependent variable only occurs when there's a difference in a single variable. In this case, Mill's method of disagreement would flag noodles as the likely cause of illness because Wei was the only person who got sick and the only person who ate noodles. Although Mill's methods begin to give us a logic for thinking about observations systematically, they're still based on a very simple idea. When we're interested in what causes a phenomenon to occur, we look for other factors that occurred or didn't occur with it. And this gives us prima facie evidence about the cause, meaning it's a starting point for understanding what depends on what. Mill's methods definitely don't settle the matter. These patterns of observations are consistent with other scenarios, including one where we haven't yet thought of the relevant factor, so there's a hidden cause, or there's some upstream common cause. We'll return to these points later, but first let's talk in more detail about experiments.